right, we are now on week 4, day 1. So let's get to work. Okay, so the first question in this week is 16 minus p, where p equals negative 12. So p equals a negative 12. So that means that's what I'm substituting into this expression so that I can evaluate. Remember to put it in parentheses because only then do I see I have a double negative and I have to turn it to positive. So that is going to give me an answer of 28. All right. So number 2 is t minus 7, okay, when t equals a negative 14. So this time I'm substituting a negative 14 into the equation. I evaluate, decide I don't need the parentheses, and I'm adding, so that's going to give me 21, and it's going to be negative. Number 3 is 13 minus x plus a negative 2, and x equals 4. So everywhere I see an x, I'm putting in a 4. I evaluate that I don't need these parentheses, so I'm going to just drop them. I don't need these either, actually. It does make it a little bit more organized. That's the only upside. All right, so 13 minus 4 is 9 plus a negative 2. It's going to give me a 7. Ugh. All right, so let's go on to question 4. Question 4 says y plus 19 equals 9. Okay, so by this time, I should know that I am going to subtract the 19 because it's being added to the y. So it goes something like this. What I do to one side, I've got to remain equal and do the other. It's going to give me a 0. And y equals a negative 10, because when I do this subtraction here, I'm going to get a negative 10. All right, let's do 4z equals a negative 32. All right, so the 4 is being multiplied to the z, so to undo it, I'm going to divide it. And z equals a negative 8. Because 4 goes into 32 8 times, and a negative and a positive give me a negative. All right, 52 equals p minus 3. The 3 is being subtracted from the p, so I need to add it on both sides. Okay, that's going to give me a 0. And p equals, if I add these two, I get a 55. Number 7, 9x plus 11 equals 110. First thing I'm going to do is subtract an 11 from both sides because the 11 is adding to the x. Okay, so I'm going to subtract it, and the rule of equality says I have to do it to both sides. That's going to give me a 99 over here. These are going to go to 0, and I have a 9x. To get the x by itself, the 9 is multiplying, so the opposite would be to divide. So your answer should be x equals 11. All right, and number 8, the question is this. Now, you guys know by now that I don't really like it when we write things backwards. So I'm going to flip-flop these two. I'm just going to make sure their signs remain where they are. So remember, when we're moving terms, the term always starts with the negative or the positive. It always has to have its sign first. So when I bring it to the front, I bring the negative to the front. And then the 8 is positive, so I put a plus there. So I have to check, make sure I got it right. In this problem, the 8 is positive. In this problem, the 8 is positive. In this problem, the 6x is negative. In this problem, the 6x is negative. I haven't changed anything, so I'm good to go. All right, so I'm going to subtract an 8 from both sides because it's being added to the x. And what I do to one side, I have to do to the other. So I'm going to subtract 8 from both sides. That is going to give me a big fat 0 here. And over here, it's going to give me a 54. Okay, so now I have to divide by -6 in order to get rid of the multiplication going on between these two. All right, and I want to take the negative with it so that it's out of my way. I know this is going to be a negative answer, okay, because I have a negative and a positive. 6 goes into 54 9 times. Ooh, these are getting longer, huh? All right, 14 equals m over 3 minus 4. Okay, I'm okay with this. If I really don't like it, I could just flip-flop the sides. Remember, you can do that as long as everything remains what it was. The 14 was positive here, it's positive here. The m over 3 was positive here, it's also positive here. The 4 is negative here, and it's also negative here. All right, so 4 is being subtracted from the m, so I'm going to add it to both sides. That's going to give me a big fat 0 there and an 18 over here. Okay, the 3 is dividing m, so to get rid of it I have to multiply it on both sides. That is going to give me, let's see, 3, 4, 5, 54. Is that right? Let me double check myself. Yes, it's a 54. All right, now we're on to number 10 and the last one of this week. Okay, so in number 10, the word problem, Acme Sports produces and manufactures 3,216 tennis balls. Each day, one container, so one container holds 3 tennis balls. How many tennis balls container are needed daily? Okay, so to be able to find out how many are needed daily, first I got to write my equation, right? There are 2 ways I could write it. I could say 3,216 divided by the 3, okay, I take that and I divide it by 3, is going to equal n, and n is how many are produced daily. Okay, but what you could have said is 3,263. That's my total, okay? That's my total amount. So it's what my equation equals. 3 balls, or how many balls go in each container, but I don't know how many containers I have. So 3n equals 3,216. And that's kind of where I want you to go with writing these equations because they're algebraic. This is just a rational expression, okay? I want these to be algebraic. All right, so to solve, this is being multiplied, so I have to divide 3 on both sides, and n equals 1072. We manufactured 1,072 containers of tennis balls in that day. All right, keep working these and email me if you have any problems, and just keep loving and doing math.